Welcome back to the Algebra 2 series, and today we're going to be looking at composite functions and inverse functions. This will be a series of 4 videos. This one is the first one, and we'll begin with composite functions. So today we're just going to be investigating a little bit of the composite, and as you see here, composite is defined as f of g. It looks like fog, but it's f of g of x, which represents or is represented by the same thing here, f of g of x. Pictorially, we see that if that's the case, then the g of x is what we consider the inner or the first function. So in our picture, we are taking numbers from this real bin here, and we are putting them into the g function, and so the answers are the g of x answers. Now those answers go into f and produce the answers to the whole composite f of g of x. Very similar to an appliance. For example, this might be the oven, and you would cook something in the oven, and then when you're finished, you would put it in the refrigerator. And so this would be the finished product of the cooked refrigerated item. So looking at that algebraically, as we see in our first example, we have 3x minus 1 is the first function, and 2x plus 5 is the second. And we're going to find each of the following items. So let's start with the first one. First, we're going to do it numerically. So part A is going to be f, and we write this f of g of, and in this case, we're just going to try the number 2. And of course, rewritten, this is going to be f of g of 2. So we're going to plug the 2 into g first. So that would be f of whatever the answer is we get for g of 2. Let me just calculate g of 2 over here. G of 2, 2 times 2 plus 5, or 9. And so that number is going to go right here, f of 9. And this time we're going to place the 9 in the f function. So 3 times the 9 minus 1, or the answer to this 26, and that's the answer to f of g of 2. And as we continue down, let me just point out here, I'm going to use the same functions, 3x minus 1 and 2x plus 5. So let's start with part B here. Second part is going to be g of g of 1/2, which is a strange concept. It's like putting it into the microwave and then putting it back in the microwave. So we're going to do it twice. In the first case, and this is, of course, we see 2x plus 5 is the function. So just put this on the side here, g of x, so we can see that it's 2x plus 5. So let's start with writing out g of 1/2. And we'll do this part first. G of 1/2 is 2 times 1/2 plus 5, or 6. So that is our number. So we're looking for g of 6, and that's going to equal 2 times 6 plus 5. So you're re-implementing the g function with the new number 6. That's going to be 12 plus 5, or 17. And that's the solution for that one. So you can see that finding these little composite values is not too hard. And then let me try one more here. Let's try this for part C. Let's try f of triangle. So in this case, we're taking the triangle and we're going to plug it into the f function, and the answer will be plugged into the f function again. And again, remember that our function here is 3x minus 1. Let's go back down here. F of x was 3x minus 1. So first we have to figure out what f of triangle is, and that's going to be f of triangle, or 3 triangle minus 1. And you can't simplify that, so you're kind of stuck with it. If that's the case, then we wanted f of triangle, or in other words, f of 3 triangle minus 1. Take that 3 triangle and plug it back in, you're going to get 3. Now what's going into the x value is 3 triangle minus 1 minus 1. That's very strange. So this becomes 9 triangle minus 3 minus 1, or 9 triangle minus 4. That was a bit strange. Okay, and that gives you f of triangle. Let's move on to the next problem. In example 2, we have two different functions. One of them is rational, the other one is radical. And for our first problem here, we'd like to find, just do another example of one of these for part A, perhaps g of f of 1/3, which is the same as g of f 1/3, like this. Well, in order to calculate f of 1/3, we'll have to put a 1/3 in there for x, and we see that's going to produce this, g of some number. And over here, I'll just do the calculation for f of 1/3. And that's going to be 1 over 1/3 plus 1. There is a fast way to take care of that complex fraction, of course. That is to multiply the top and bottom by that denominator 3 that you see right here. And if we do that carefully and distribute that in the top and bottom, we end up with 3 over 1, because the 3's cancel in that first case, plus 3, or 3/4. So 3/4 is the value. That's the number that I'm going to put into the g function, 3/4. So g of 3/4 would be the square root of 3/4, or the answer, radical 3 all over 2. And that is good enough. Let me do one last problem here. So that's the first one. The next one we want to try is something like this. Maybe perhaps g of f of some number like 2. And when you do that, of course, f of x, we just did a second ago, that's 1 over x plus 1. So if we did f of 2, we'll produce 1 over 2 plus 1, or 1/3. And that's going to be plugged into g. Well, g of 1/3 is simply the square root of 1/3. So that's the answer. And of course, some classes, they would like you to rationalize that. That's the square root of 1 over the square root of 3. That's 1 over the square root of 3. Or simplifying that out, I don't know if I'd call that simplifying, but anyway, radical 3 over 3 would be an answer that would be appropriate for g of f of 2. I'm squeezing that in over there. Okay, so that would be the other way to do it. And for this video, let me finish out by working on calculating f of g of x. So in this case, I'm not using any numbers over here anymore. I'm just going to do f of g of x. Let's start with this first one here. F of x, 2x plus 1. G of x is x minus 3 all over 2. Now, if I'm going to put f of g of x, then that means f of g of x. So the g function is being placed in the f function. So drawing the picture here, that means this guy is going right there. And let's just do the calculation now. That's going to be 2. And instead of an x, we're going to have an x minus 3 all over 2 plus 1. The 2's cancel here, leaving us x minus 3 plus 1, or the final answer, x minus 2. And notice that f of g of let me rewrite that. F of g of x is a new function. So it's almost like a shortcut function. If you recall, when we did the picture, and this is going into g, and then it's going into f. So what we're learning here is that a composite function is a function in itself. Notice that in this function, the g function is this guy over here. So it subtracted 3 from the number and then divided by 2. And it went into this bin as the g of x function. And when it was done, then what did we do after that? Well, then we multiplied it by 2 and added 1. And that's what we did when we came into f. And so over here, we end up with the answer for the combination, or the composite of the two. Well, what we're finding here is that there's a shortcut. That all we have to do is take x minus 2, and that's just as fast as doing both of those items. So the f of g function is actually a fast way to do the two things, one after the other. And that's why we calculate these composites. Well, finally, I want to finish out with the hardest of the computations, and that is this one. It's a situation where the two functions are rational. So f of x is something like 2x plus 3, and the denominator x minus 1. G of x is also rational, x plus 3 over x minus 2. And when you have a situation like this and we're trying to calculate f of g of x, that means we have to take this big monster right here and plug it into here and also into here. We're going to create a fairly large fraction then. It's going to have a 2, and then it's going to have another one down here, minus 1. So a 2 times that quantity. And what's going inside the quantity is the actual g of x function, x plus 3 over x minus 2. Again, x plus 3 here, x minus 2. Now what we learned from the previous page is that if we multiply the top and bottom of this fraction by that denominator, and this is x minus 2, this is the number that's in the denominator. We're going to have to do this carefully. This is x minus 2 here, and x minus 2 over here, x minus 2 here, and x minus 2 over there. We should be able to take care of this complex fraction fairly quickly. In the first case, the first one is up here. You see that we cancel the x minus 2, so we're left with the original 2 and just the x plus 3 left over. In the second multiplication, we leave the 3, and we're left with the x minus 2. Going on to our denominator, in the first part, as we multiply it across here, we end up with an x minus 2 canceling and just an x plus 3. And finally, the x minus 1, the negative 1 gets multiplied by the x minus 2. Now, of course, we don't want to cancel anything here because we have quantities in the top and bottom. So those we want to instead combine terms in the top and combine terms in the bottom and simplify it out. So that's 2x plus 6, I'm distributing the 2, plus 3x minus 6, the denominator x plus 3 minus x plus 2. Oh, I had to be careful with that negative there. And then finally, let's rewrite this as 5x. The 6's drop out in the top. In the denominator, the x's drop out, and that's just with a 5. And lo and behold, our answer is a simple little x. We'll just put a happy face next to that. What a fun way to end the video is by simplifying all the way down to x. We'll continue this in segment number 2.